All right, hello again, and we're going to talk about functions and modules. So we've actually worked with some functions and modules as well. We briefly looked at the math module. Okay, so we're just going to go into more depth here. Okay, so recall how to write functions that do not require arguments, accept one or multiple arguments, return no value, one value, or multiple values. So for some of you, that might mean nothing to you right now, but hopefully by the end of this session, these things will begin to become more clear. Okay. So different types of functions. So one of the main types of functions are built-in functions. So the Python interpreter has a number of functions and types built into it that are always available. So example functions that are built in, always available, are type, print, input. So we've used print and input. We've used int, round, and repr. Okay, so those are built-in functions that we've been using. And then we have functions available from built-in modules. So there are many modules available for Python developers to use. These modules provide more functions for us to write our programs with. Example modules, math module and random module. Example functions, math.square root and math.sign, math.degrees, random.random int, random.choice. So notice that these functions are not built in. We need to name the module that the functions are coming from when we call the function. See, so the name of the module is math and the function is square root, is sqrt, right? And that's what that statement means. Okay. One other type of function is methods. Now, in other language, all functions are just called methods, but in Python, there's a distinction. So methods are just like functions with two major differences. Methods are defined inside a class definition in order to make the relationship between the class and the method explicit. The syntax for invoking a method is different from the syntax for calling a function. We have seen methods in grade 11 when dealing with graphics mainly. So window equals tk, window.title, and then window.geometry. So these two title and geometry are methods because window is an object of class tk. So we don't focus too much on this aspect. Once we get into classes and modules or classes, object oriented programming, right? Then this will make sense and we'll understand better. But for now, we just need to understand that, you know, understand functions from a basic level. Okay. So title and geometry are methods, and you can see that when they're called, that they are appended to the object that they are acting on. More on this later. Okay. User defined functions. Now this is where we come in. A Python programmer can create their own functions. These functions are called user defined functions. The idea is that there is something that you want to do in your program and there is no existing function that does it. Then you can create the function yourself. Learning how to program with functions will make your code reusable, since once a function is defined, it can be used over and over and over again. Functions, or modular programming, also allows for the splitting of very large programs into pieces that have a well defined role. This is very, very, very important. Um, this last paragraph is very important. As a matter of fact, expect this to be on a test or final exam for sure. Okay. So again, reading again, learning how to program with functions will make your code reusable. Why is that important? Imagine that we're making a large, we're this class, we're actually a development team and we're working on an application that's going to be used in schools, right? So it's going to be big, right? And imagine that there is as we're writing the code, we find out that, oh, okay, like we're doing a lot of copy and paste. What, we copy and paste something from one part of the code, and we copy something from one part of the code and we paste it in another, right? Now, if you find yourself copying and pasting code, that means that there's an opportunity that's called code duplication, meaning that you're just duplicating the same code over and over again, which means that there's an opportunity for you to put all of that code into a function. So you can imagine that the print function actually has it's it has a whole bunch of different steps in the code that eventually does your print for you. But we don't see any of that. All we need to do is just write print. We need to put our stuff in there and we know that it works. So that's the whole concept, right? Is that we can stuff all of our interesting code into a function, and then whenever we want to use that code, all we need to do is call the name of the function and give it the arguments that it's looking for, and it will do what we've defined it to do. So that's important. And then it also allows us to organize our code, right? So if you're writing a very large application, it needs to be organized. It needs to be split up logically so that it's easy to read, it makes sense, and it can be understood by other developers. So creating functions. Functions are created using the following syntax. So this is a keyword, and it's very important. Def. So once Python sees def here, it knows that we're dealing with a function. So this is like defining a function. Then we have the function name. So my function name, and follow this naming convention here. Then we have two arguments, arg1, arg2, colon. So this line is called the function signature, right? So whenever you use the function, you have to call the name, and then you have to give it two arguments inside here, separated by a comma. And then here's the function body, or the block. Do something. So these are just statements. Do something else, blah, blah, blah. Return. Now, return. So this function will return some sort of information back to us, and it will be stored in these two variables. So here, a function has two main components, the heading and the body. Okay, so let's move on. So example of a function that has one argument and no values returned. So write a function called num underscore diag that calculates the number of diagonals d in an n-edged polygon, and then prints the value to the screen. So this is the formula to do that. So we don't need to understand exactly what that is. This is not a math class, but here's the formula. So we're trying to get this answer d, right? And d is calculated by doing n minus 3 first, multiplying it by n, and dividing it by 2. So this is test your function to calculate the number of diagonals in an octagon or dodecagon. So here is the function, what do we call it? We call it the heading, okay? And it takes one parameter or one argument, and it's named n. And so here's the body, and so here's how we calculate it. D is equal to n times n minus 3 all divided by 2. And then we print the number of edges are, and then d, whatever the answer is. So notice that no values are returned because we don't have a return statement here. It doesn't have a return keyword. Okay, so no return statement. This means that no values are being passed back to the main program. So when the function is called, we simply call it. We do not do this. Answer equals. So we do not do this. Answer equals this because this function doesn't return anything for answer to store. So we just in the main program, we can just write this, and then it will print when it executes. It will print out this. And this is actually something that we did for assignment one. Was that if you look back and notice, I defined a function, and then all you guys did was just write this line in the function. Okay. 3 arguments, 1 value. So 3 arguments, but 1 value returned. So write a function called smallest int, which takes 3 integers and returns the smallest of the 3 values. Test your function with the values 5, -1, 7, and 0, 0, 4. So here's the function heading. This is the function name, smallest underscore int. These are the 3 arguments, x, y, z. So we say numbers equals, now you don't know what this syntax is with the square brackets, but this is saying that this is a list. Okay, so numbers equals a list containing x, y, and z. Smallest is going to equal, now this is I believe this is a built-in function called min, and min will look inside numbers and will automatically give you the smallest number. Okay, and then we return what smallest is storing. So how do we use it? We can print this, or we can call the function with these numbers and then store the result inside answer and then print answer. So, okay, so since the value is being returned, we need to do something different in the main program when the function is called. Here is 2 different ways that you can print out the value returned. So here's another example. No arguments, 2 values returned. So this is get 2 integers, and we're looping inside here. So it says, so there's no arguments in here. Notice, no arguments. So while true, try, we have the try except again. Try getting input for these two numbers, and then put them in these variables and break. Otherwise, tell the user that we want an integer, please, and then return x and y. Main program. Now, if we want, so now we can, this is new to you, but we can have 2 variables here separated by a comma on the left-hand side, and get 2 integers. This function returns x and y. So x will go here and y will go here. And then when you print them, you can get the value. You can see what's in there. So since 2 values are being returned, we need to ensure that both values are being assigned to a variable when the function is called in the main program. Exactly. So that's why we need these 2 variables separated by comma like this. Okay, so that's all we got on functions. Okay, we'll be delving deeper into them in I believe the next unit. Okay, so this is just a brief review of functions, but we'll be defining our own for sure. Okay.